Good evening. Good evening to all. Today I am going to explain you very important model. Very important model from number system, that is proofs of irrationality. Am I audible now? Am I audible? Good. So it will shake after some time, it will stop, no worries. Now, before going to this problem, we need to understand one concept, that if A is a composite number, and P is a prime number, A is a composite number and P is a prime number, if P is a factor of A square, then P is a factor of A also. This is what you have to understand. Okay, children? If P is a factor of, if A is a composite number, P is a prime number. If P is a factor of A square, then it is a factor of A also. This is one important statement that you have to keep in your mind. Okay, now I will give you one example for this. 5 is a factor of 100, and 5 is a factor of 10, which is 10 square, then it is a factor of 10 also. That is what you have to understand. 5 is a factor of 100, which is 10 square, then 5 is a factor of 10 also. Okay, now? Now, this is one. The other one is co-primes. You have to know the concept of co-primes. Suppose co-primes means two numbers, if their highest common factor is 1, then those two numbers are said to be co-primes. Okay, na? Two numbers, for example 8, 9. Consider two numbers 8 and 9. What are the factors of 8? 1, 2, 4, 8. What are the factors of 9? 1, 3, 9. What is the common factor? 1 only. What is the common factor of 8 and 9? 1 only. So 8 and 9 are called co-prime numbers. 8 and 9 are called co-prime numbers. Another example. Consider 23, 24. Consider 23, 24. Factors of 23, 1 and 23. Factors of 24, 1, 2, 3, 4, 6, 8, 12, 24. Now common factor is 1 only. Common factor is 1 only. So 23 and 24 are called coprimes. Is that understood, children? So we can say that any two consecutive numbers are always coprimes. Any two consecutive numbers 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, na? So they are coprimes. Okay, na? Now, so these two statements are very much important for proving irrationality. Now, I am considering, I want to prove root 5 is an irrational number. I want to prove root 5 is an irrational number. Okay. How to prove it? For this, I will approach, or to solve this problem, I will use method of contradiction. I will use method of contradiction. What is method of contradiction? First try to understand that one. Method of contradiction means whatever we have to prove, let us assume that it will not happen. Here we have to prove root 5 is irrational, and we will assume that let root 5 is not an irrational number, it is a rational number. Let us assume, okay, root 5 is a rational number, but we have to prove it is irrational, and contrarily we are taking it as a rational number. Okay, na? We are considering root 5 as a rational number. Camera shaking. I don't know why it is shaking. Maybe problem. You are not able to see properly. Yesterday it was not like that. Today it is shaking very much. Yesterday it was okay. I don't know what happened today. Okay. And A and B are integers. B is not equal to 0. Moreover, A and B are coprimes. A and B are coprimes. Okay, they are coprime numbers. That means highest common factor for these two numbers is 1 only. Okay. Now, square it on both sides. 5 is equal to a square by b square. If you square it on both sides, sir can't see, sir. Nirma, what to do, you tell me? Maybe sensor problem. You can't see. That much is not shaking, na? Now, then from this, if you do cross multiply, what we will get? A square is equal to 5b square. A square is equal to 5b square. Now, so from this, b square is equal to a square by 5. b square is equal to a square by 5. Now, what we can say? If here we can say clearly that 5 is a factor of a square, because when we divide a square with 5, we are getting result as b square and no remainder. Okay, na? When we are dividing a square with 5, we are getting b square is the answer. So clearly we can say that 5 is a factor of a square. Okay. Now, since prime is a prime number and it is a factor of a square, we can clearly say that 5 is a factor of a also. 5 is a prime number and it is a factor of a square. Then clearly we can say that 5 is a factor of a also. Okay? Now, observe this one. 5 is a factor of a. That means a can be expressed as some 5x. See, I'll give you one example. That 5 is a factor of 10. Then 10 is the multiple of 5. 3 is a factor of 27. Then 27 is a multiple of 3. Is that right? For example, 3 is a factor of 15. Then we can write 15 as some 3 into 5. Is that right? Okay. So in the same way here, 5 is a factor of a, then a can be expressed as some 5 into x. Okay, children? Now, insert this value in this equation. A square is equal to 5b square is there, na? Now in the place of a, you insert 5x. 5x whole square is equal to 5b square. 25x square is equal to 5b square. Then b square is equal to 25x square by 5, which is 5x square. B square is equal to 5x square. Okay. Now, from this, x square is equal to b square by 5. X square is equal to b square by 5. So, from this what we can say? 5 is a factor of b square. So, therefore, 5 is a factor of b also. Let it be equation statement 2. Let it be statement 2. What the first statement says? 5 is a factor of a. Second statement, 5 is a factor of b. So, from 1 and 2, we can say that 5 is a common factor of a and b. 5 is common factor of a and b. 5 is a common factor of a and b both. But what we have taken here, a and b are co-primes. A and b are co-primes. That is what we have taken. Okay. That means A and B are not having any other common factors other than 1. What we have considered here? A and B are co-primes. That means they don't have any common factor other than 1. But what is the conclusion we got? 5 is a common factor of A and B. మనం తీసుకున్నది ఏంటి? What we have taken and what we got. Exactly opposite. Whatever we have considered and whatever we got at the end, both are different. Why this situation arises? Which is absurd, na? Which is absurd. We are in an ambiguous situation. We are in an ambiguous situation. Is that right? What is the situation? We have taken one thing and we have got in a different way. We have got a different answer. Is that right? So this situation arises, this ambiguous situation arises because of an incorrect assumption that root 5 is an irrational number. This situation arises because of our incorrect assumption that root 5 is rational. So it is not rational, it is an irrational number. Is that understood, children? Is that understood? Yeah. Okay, na? So this is very, very important model. Now, see. Now, there is another type of questioning that prove that 2 root 3 plus 5 is an irrational number given root 3 is irrational. This is one. Another model in this. Prove that root 2 plus root 3 అయిపోయింది ఫోన్ స్థాయి అయిపోయింది. మరి ఎక్కువ షేక్ అయిపోతుంది. Okay. Prove that 2 root 3 plus 5 is an irrational number given root 3 is an irrational. Okay. Now, let, again contradiction method, let 2 root 3 plus 5 is a rational number. Let us assume 2 root 3 plus 5 is a rational number. Okay. Again contradiction, method of contradiction. Okay. Now, send this 5 to that side. 2 root 3 is equal to a by b minus 5. 2 root 3 is equal to, take LCM, b, a minus 5b. Root 3 is equal to a minus 5b by 2b. Up to here. Now, what is this? Can anyone say? What is this? Root 3. What is root 3 there? Given it is irrational. Root 3 is irrational. Okay. Now, what can you say about this? a minus 5b by 2b, a minus 5b by 2b. See, a by b is a by b rational, na? If we subtract a rational from rational, the result is rational only. If we divide a rational with another rational number, result is rational only. So this is also in b by q form, na? A minus 5b by 2b is also in b by q form, which is rational. So root 3 is irrational given. Root 3 is irrational given. A minus 5b by 2b is rational, we know it. Because a by b is rational, then a minus 5b by 2b is also rational. Okay. So what we got answer? What we got as answer? An irrational number is equal to a rational number. An irrational number equal to an irrational number. Okay. Which is a wrong statement. Which is a wrong statement. Which is absurd. So why we are into this situation? Why we are into this situation? Because of our incorrect assumption that 2 root 3 plus 5 is a rational number. It is not a rational number, it is an irrational number. Okay na? Root 3 is irrational. A minus 5b by 2b is rational number. Therefore, root 3 is not equal to a minus 5b by 2b. It is not equal. So, this situation arises due to our incorrect assumption that 2 root 3 plus 5 is equal to a by b is a rational number. So it is not a rational number, it is an irrational number. If you want, you can take it as a screenshot. Sir, can we prove that root 3 is irrational? And yeah, you can do like that, but it is a lengthy process. Why we have to go with that? No need to see, sorry Pardu, you cannot do like that. Right? Given root 3 is irrational already. It is given root 3 is irrational. Then why to prove it is irrational? You can't do like that. If it is not given that root 3 is an irrational number, then we have to prove that it is irrational. But in this sum, it is given clearly that root 3 is irrational. So no need to prove it. No need to prove it. Okay? Root 3 is irrational number. A minus 5b by 2b is rational number. So root 3 is not equal to a minus 5b by 2b. Yes, one more problem. Prove that 1 by root 2 is irrational. Given root 2 is irrational. Given root 2 is irrational, prove that 1 by root 2 is irrational. Given root 2 is irrational, we have to prove that 1 by root 2 is irrational. Okay, na? Now consider 1 by root 2. Consider 1 by root 2. Rationalize the denominator. Rationalize the denominator into root 2 by root 2. So you will get root 2 by root 2 whole square, root 2 by 2, and we can express this one as root 2 by 2. We can express it as a half of root 2. Is that right? Root 2 by 2 we can express it as half of root 2. Okay. Now 1 by 2 is a rational number. Root 2 is irrational. Irrational number. It is given. Root 2 is irrational given. Then product of a rational number and an irrational number is always irrational. Product of a rational number and an irrational number is always irrational. So 1 by root 2 is irrational. Is that understood, children? So basing on this, we will get different models, only two models. One I told you now, root 5 irrationality proof. Prove that root 5 is irrational, root 2 is irrational, root 7 is irrational, root 10 is irrational. That is one model. And second model is given root 5 is irrational, prove that 2 root 5 is irrational. Given root 3 is irrational, prove that 2 minus root 3 is irrational. Given root 7 is irrational, then prove that root 7 plus 2 is irrational. So these are the only two models in this chapter. One is proving root 2, root 3, root 5, root 7, so on as irrational numbers. That is one model. And second model is like this. So in this model, it will be given to you that root 5 is irrational, root 3 is irrational, root 7 is irrational, here root 3 is irrational. It will be given to you. Then you have to prove that that number is irrational. So only two models will be there. Okay, na? So by this chapter ends. Okay. We have to move on to the next chapter, that is polynomials, from tomorrow. Okay. So even tomorrow also you have a class. Don't miss it. Today only 28 students are attended to the class. Thank you very much for you 27 people for giving me an opportunity to clear your doubts. Thank you very much. Dhanyavad. So if anyone is there who not subscribed to this channel, you can subscribe, because there are many videos on Vedic mathematics which is very much useful to you for simplifications and all those. If you are not subscribed, subscribe it now, and if you are not like this video. Thank you very much. Dhanyawad.